Okay, welcome to Unit 2. Congratulations on surviving Unit 1. We weren't sure that you would all make it, but here you are. Let's take a look at, this is Chapter 2-1, 2-2, and 2-3 in a nutshell. Should be a large nut. Hopefully you've done the page on the back of the calendar for this unit, because a lot of what we need is going to come from there. So patterns and inductive reasoning, we need a description of these words and then a picture or an example of what they are, what they mean. So go ahead and try, see if you can use, a dictionary, the glossary, the internet. Try and get some descriptions and some examples of here. Pause the video. When you get back from the video, I'll give you my answers. So hopefully you pause the video, but if not, I'll give you mine in just a second. Go ahead and pause the video now. Alright, you've unpaused. Here are my answers to all of these. So a conjecture is a conclusion you reach. It's a guess. For example, I think it's going to rain today. If it's cloudy outside, I might say that. A counterexample is an example that, is an example that shows a conjecture is false. So all tall people are funny looking. Perfect counterexample of that is me. I am not funny looking. I am amazing looking. Inductive reasoning. That's reasoning based on the patterns you observe. I've seen a lot of cloudy days, and on the cloudy days it rains a lot, so that I'm using that reasoning to make my conjecture up here. Truth value, if it doesn't rain today, alright, my truth value, the truth value of my statement was false. Pattern is a tough word to define, because we all know what it means, but it's tough to define it. The dictionary defined it as a repeated form of design. I hate the dictionary definition. But we all know what pattern is. It's just an odd definition. And I just put 1, 2, 4, 8, 16. Obviously the pattern here is that it's doubling every time, right? So we're going to make a conjecture about the rule. Use inductive reasoning to find the next two terms. Go ahead and pause the video here. See if you can get the next two terms on each one of these patterns. Go ahead and pause the video now. And when you unpause it, I'll have some answers for you to check. Alright, so you've unpaused. Let's check your answers against mine here. 18 and 21, the pattern here is counting by threes. Here, this was AB, skip C, DE, skip F, GH, skip I, JK. Those are the next two. Here, with the numbers again, I was dividing by 3 each time, so 1/9 divided by 3 is 1/27th, 1/27th divided by 3 is 1/81st. And then here, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. That's the pattern there. Hopefully you did pretty good on those. Find one counterexample to show each conjecture is false. So a counterexample is, again, it's just an example that proves something not true. So it says the sum of two integers is always positive. Well, if I add -1 plus -2, that equals -3. And that right there is a counterexample. That's all you got to do. All four-sided figures are rectangles. Was that true? No, it's not true. It's got a truth value of false. And somebody tell me a four-sided figure that's not a rectangle. If you just talked while you had headphones on, that's funny. Four-sided figure, let's go square, but I could have listed a rhombus, trapezoid, kite, parallelogram, all sorts of other stuff. Alright? Determine the truth value of each statement. If false, give a counterexample. So all angles are acute. Is that true or false? Well, we know that's, yikes. Oh man, that is ugly. We know that's false, and, some angles are obtuse. Okay, so that's pretty easy. If an angle measures 80 degrees, then it is acute. Well, it's cute. It's adorable. Then it is acute. And that, the truth value there, is true. Easy enough, right? Just using our brains. Chapter 2, Section 2, and 2, Section 3 talk about conditional statements and then something called biconditional statements. Okay, we use conditional statements all the time. All right, I'm going to fill this in for you and then talk about each thing, okay? So we'll go one at a time. We'll fill this in. We'll start with conditional statement. So a definition here of conditional statement looks something like this. It's just an if-then statement, okay? That's all a conditional statement is. It's an if-then statement. Alright, an example of an if-then statement, just, I don't know, off the top of my head, whatever comes out first, I guess. If you're tall, then you're awesome. Alright, that's an example of an if-then statement. In symbols, we would write that with the letter P and then an arrow pointing to Q. And how do we read that? If P, then Q. So we just take out the words and put in the symbols. The hypothesis. Okay, the hypothesis is the part of the if-then statement following the if. So the hypothesis here would be that you're tall. And the symbol for that is just the P. All right. The conclusion would be the part following the then. So you are awesome. Okay, don't get excited. It's just a conclusion based on an if-then. So, and the conclusion there is Q. The converse of that statement, on the converse, we exchange the if and the then. So, if you are awesome, then you are tall. The converse switches places, okay? The symbols there is we just switch the P and the Q. So now it's Q, then P. And we read that if Q, then P. To negate something means we make something the opposite. Okay, so you don't always want to say negative because if it starts negative, then you would be making it positive. So you make it the opposite. So if you're not tall, then you're not awesome. All right, and the symbol for negation is this little squiggly. All right, so if not P, then not Q. And if we were actually write that out, the negation with symbols, the whole thing, it would look like this, with the squiggly P, then the arrow, and then squiggly Q. All right, squiggly is a very technical term. All right, then we got some more. Inverse, contrapositive, reversible, and biconditional. So let's take a look at those. Go ahead and work on these fill in the blank, and then we'll just go through and I'll give you some correct answers. But I need you to pause the video here and actually do the fill in the blanks on your own so that then we can check them. So pause the video now, please. So I want to walk you through these to make sure everybody's on the same page. So the conditional, hopefully you've filled in some of these in the other practice, and if not, that's okay. We'll walk through them. The conditional and its contrapositive are always both true or both false, so they have the same truth value. The converse and the inverse also have the same truth value. However, the conditional and contrapositive may have a different truth value than the converse and the inverse. Okay, so there's a lot of fill in the blank there for you. Let's take a look at the next page. Hopefully you did these. Again, if you haven't done these yet, pause the video, do the rest of the practice. I'm going to walk you through all the answers. A conditional is divided into two parts, the hypothesis and the conclusion. And then we had to write out the converse here, so that's where we switch we switch the beginning and the end. The inverse, that's where we make the beginning and the end both we negate them. We make them both negative unless one of them already is negative. And then the contrapositive is when we do both. We negate and switch. Identify the hypothesis and the conclusion. So I've done that. The hypothesis here is a number is a multiple of 2. The conclusion is a number is even. Make this a little bigger. Maybe you can see a little bit. Yikes. And so the conclusion is the number is even on the second one. 2 angles are supplementary. That part is actually the conclusion because if the angles form a linear pair is the hypothesis. All right. Let's take a look at the next one. The truth value here, that's true. And then the converse of that, we switch directions, and that also happens to be true. Let's take a look at the next one. Truth value here, that's true, and then the inverse is also true. I'm sorry, the inverse is false. Yikes. If an animal is not a fish, then it does not live in the water. That's not true because there's all sorts of animals that aren't fish that do live in the water. Here we have the truth value there, that's true, and then the contrapositive also happens to be true. If you're not getting these fast enough, pause the video, by the way. You should have something written down already and you're just checking. But if you need to, you pause the video. Here's the biconditional, okay? First we reverse it, it's the converse. And because they're both true, it is reversible. And so then we can write the biconditional. Remember, you can also write, if you don't want to write out if and only if, you can write IFF. That works, okay? And then here, when we reverse them, we see it's not reversible. It's not true in both directions. Here, I'm given a biconditional, and I have to separate it into 2 conditional statements. This sometimes is hard for students. So it says a parallelogram is a rectangle if and only if the diagonals are congruent. So one of the if-then statements, one of the conditionals could be if a parallelogram is a rectangle, then the diagonals are congruent, and then I just write the converse. And then I've done the same thing here at the bottom. And that's it. We'll do the practice tomorrow in class. Good job, and see you next time. Bye.